Hi students, welcome to exercise 11B, solving trigonometric equations. So same thing as 11A, except this time we're looking at the general solution. What the general solution means is you're looking at all the possible solutions. Okay, so if you just look at the unit circle and you go around and around and around, technically at that point all those answers will be true. So for example, sine of pi over 4, that is equal to sine of 9 pi over 4. So those are two different angles that give you the exact same solution of square root of 2 over 2. And there are an infinite amount of solutions because you can keep going around the unit circle and arrive in the same point every time, and that would give you the same value for sine. So if the domain is all the real numbers, there are an infinite amount of rotations. So if, for example, if we don't give you an interval, if we say we want all the solutions, that's when the general solution comes into play. Alright, so basically, at the end of the day, this is going to be try to simplify it as much as possible. To determine a general solution, you find the solution in one positive rotation. So find the answers that you normally would. And then we're going to use a notation that's going to explain that you're going to add rotations an infinite amount of times, depending on where you want to be. Okay, so the different ways you can ask for a general solution, like in the question, for example, it could say, oh, the domain is all the real numbers. It could say a variable, so depending on the variable you're working with. So x and theta are the most common. X is the element of all the real numbers, so kind of the same thing as saying that. And we could also ask for the general solution. Okay, well, let's answer the first one. The first one's a pretty easy question. The first one has a normal domain of the first revolution, right, from 0 to 2 pi. So that's just one revolution around the circle. Alright, so the values for cos equals the square root of 2 over 2. That comes from our unit circle. It's an exact value. I hope you recognize this is an exact value. So the answers for this problem would be pretty simple. It would just be x equals to pi over 4. And x equals to 7 pi over 4. Because since cos is positive in the first and fourth quadrant, you have an answer in the first and fourth. So just to visualize where those answers would be on the unit circle, so imagine this is a unit circle. This would be your pi over 4 over here, and this would be your 7 pi over 4 over here. Okay, so what if we ask for the general solution? Remember, this means what is for the general solution? It means that if I was on this point and I added a circle, and I landed there, it would be 9 pi over 4. That would give me the exact same solution. What if I added another one? Okay, we'd be at 17 pi over 4. I think that's right. 17 pi over 4, you'd be there again, and so on and so forth. You could go in the other direction as well. So what we would do is we'd take the x equals to pi over 4, and we would add a certain amount of revolution. And if you guys remember what one revolution is, it's 2 pi. So you add 2 pi. That's one revolution. But how many times do you add 2 pi or subtract 2 pi? Right? Because you go in the other direction. Well, that's what this k value is going to represent. Because you don't know the amount of times you want to add or subtract. You just know that this k value can be any number. Okay? But it has to be a full revolution. So we have to say that k is an element of the integers. What this means is that k must be a whole number. So k can be 1, 2, -5, -10. And all that means is it's going to add a certain amount of even revolutions, so that way you end up at that point. But notice that we have 2 points, right? We have this one and we have that one. So we have to do the exact same thing to the second point. We take that point, 7 pi over 4, we add 2 pi k. So again, this is an unknown number of full revolutions, as long as k is an element of the integers. Again, integer is a whole number, so you have to add complete revolutions from this point and always land there. Okay, a few more examples, kind of the same idea. So solve tan theta equals to -4 over the interval 0 to 2 pi. So again, we want all the solutions in the first revolution. So that part's easy. Notice that even if you ask for the domain of all real numbers, you would actually still do this step no matter what. This is just an extra step on top of that. Alright, so this is not an exact value, right? So you're going to try to find the angle of reference. So you're going to find the angle of reference by taking the inverse tan function, right, tan negative 1 of 4. Don't forget, again, I'll repeat it, that and every time you find the angle of reference, you will not take a negative there, always positive. Okay, so now you plug that into your calculator, and notice that we want it in radians, right? This is radians. So you make sure your calculator is in radians, and you're going to find the value of 1.3258. What I usually like to do when I work with trig functions, and anytime I'm using my calculator, I try to just, I cut off after 4. We want to always be correct to 3 decimal places in this course. So if I write all 4 numbers, you're for sure correct to 3 decimal places because you have the 4th digit. So that's my reasoning on that. All right, so the angle of reference is 1.3258. Now we have to find out, well, what quadrants are we trying to find? Well, again, you go look back to your original question and you say tan is negative. Well, tan is negative in quadrant 2 and 4. Perfect. So you need an angle in quadrant 2. And the way we're going to find an angle in quadrant 2 is you would have pi. So don't forget we're working with radians. So pi, and you would subtract the angle of reference. So you'd have pi minus the angle of reference, which is 1.3258. Okay, so again, that's a radiant value, right? So 1.3258 would be probably around 70 degrees-ish. Okay, so then your angle in the second quadrant, you're going to complete this operation here, pi minus 1.354, so I'll do that on my calculator. So minus 1.358. So your answer is 1.8157. So again, I'm truncated to 4 places. So that's your angle in your second quadrant. Don't forget 3.14, that would be this, right? 1.57 would be that. So anywhere in between those two, 1.57 and 3.14, that would be 1.8. So that works. It's in the second quadrant. Okay, we're going to do the same thing for the fourth quadrant. So try to put a V there. So in the fourth quadrant, to find an angle, you got 360, or in our case, 2 pi, and you subtract the angle of reference. So you have 2 pi, and we subtract our angle of reference, which is 1.3258. Okay, again, you're going to have your calculator. So our angle in the fourth quadrant is equal to we have 4.9573. Okay. So those are the two solutions from 0 to 2 pi. Okay, so if this question was asked, find the domain if it is all the real numbers, you would do all of this work. Same thing, except what you'd have to do is take these two solutions and add the exact same things we added the last one. So you would take your angle of 1.8157 and you would add your 2 pi k. So you're adding an unknown amount of revolutions to land on every single possible answer, and that will happen if k, if k is an integer. And we use the letter I to represent integer. And we do the exact same thing for the other one, 9573, and you add 2 pi k, and k is an element of integers. Okay, we're going to do one more. We'll do it in degrees this time. Usually what we're asking for general solution, we're asking for radians, but it is possible we work with degrees. So let's find the answer to this between negative 360 and 360. So cos theta, or cos beta, so I'm losing a different angle. It's just like x or theta, it's another Greek letter. This one's beta. So cos beta equals 0. So when is cos equals 0? So I look back on my answers here. Cos is x. When is x equals 0? At those 2 points. So if we were asked for this interval here, we would have beta equals 2. Let's go around. So 90. So 270. So I'm just stopping. Every single time I stop, I'm giving an answer. And if I keep going, 270, 360, I'll go past. So therefore, I'm done for that one. So now what if I go in the negative revolution? So I start here because there's a negative revolution and a positive one. So I go negative 90 degrees. So beta equals to negative 90 degrees. And you keep going, so negative 270 degrees. Okay, so this would be the solutions on that interval. Now the general solution, right? We're going to try to simplify this a little bit. The general solution here, notice that it's every 180 degrees, right? Because if I go there, and there, and there, and there, it's every 180 degrees. So in that first page, we were there and we go back here, but there was no same interval between those 2 points. So here, I'm going to say beta is equal to 90 degrees. So we're going to take our starting point over here. So 90 degrees, and then we're going to add 180 degrees a bunch of times. So add 180 degrees a number of k times, right? So if you add 180 once, twice, 3 times, you can either subtract 180, subtract, subtract, subtract. You keep landing on the same 2 spots. So k is an element of the integers. So this would be a simplified version of the answer. Another version, so we're going to write or, so this would be a non-simplified answer, which is also correct. You could have said 90 degrees plus 360k. K is an element of the integers. So just add a full circle every time to 90 degrees. And you could have said beta equals to 270 degrees plus 360 degrees. K is an element of the integers. So this would be also another possible solution. So this or that. Okay, I'm sure we'll discuss this in class, guys. But good luck. I hope you understood the majority of this.